Hi guys, today I'm gonna discuss about a lesson called functions in discrete mathematics. First up, what is a function? Function, also called mapping, is a relationship from elements of one set X to elements of another set Y, such that X and Y are not empty sets. X is called the domain, while Y is called the codomain of the function f. Please note that a function can be one-to-one or many-to-one, but not one-to-many. But this may vary on the different types of function, which will be discussed by Mr. GAVRIEL DONASCO later on. So here will be the graphical representations of a function, just like Venn diagrams, graph, or a plot. A not function will be defined like this, because as you notice, there are some values that are left alone that has no connection to the set Y, just like the 3 and the Y here. That's not allowed in a function, as well as this one-to-many, which will be noted in the definition of functions. Here shows the pre-image is the value of the domain X, while the value in the codomain Y is the image. The process or the result of the pre-image will be the image. For example, we have a function of x squared, so the values of x will be squared, and that will be the value of the y. Just like here, the value in pre-image will be the image, as well as the range, which covers all the values here in the domain function. Just like here, the values in the domain is all in the inside of the range, while as you notice, there are 3 variables or values outside the range that has no connection in the domain X.
Injective or one-to-one function. Injective means we won't have 2 or more a's pointing to the same b. For example, domain A consists of numbers 1, 2, and 3, and those numbers are pointing to the codomain that consists of letters A, B, and C. So many to one is not okay, which is okay for a general function. As it is also a function, one-to-many is not okay, but we can have a B without a matching A. Injective is also called one-to-one. A function f a to b is injective or one-to-one function if every b element of b there exists at most one a element of a, such that function s is equal to t. This means a function f is injective if a1 is equal to a2, implies function a1 is equal to a2. The next is surjective or onto function. Surjective means that every b has at least one matching a, maybe more than one. So, for example, domain A consists of numbers 1, 2, 3, and 4, and codomain B consists of letters A, B, and C. Codomain A can consist of at least one matching A. There won't be a left out B. A function A to B is surjective onto if the image of f equals its range. Equivalent, for every b element of b, there exists some a element of a, such that function a is equal to b. This means that any y in B, there exists some x in A such that y function of x. The last one is bijective or one-to-one correspondent. This consists of both injective and surjective. So there is a perfect one-to-one correspondence between the members of the sets. But don't get confused with the term one-to-one. Used mean injective. Bijective function have an inverse. If A goes to a unique B and every B has a matching A, then we can go back and forwards without being led astray. This is bijective. A function A to B is a bijective or one-to-one correspondent if and only if f is both injective and surjective.
Composition of functions. In mathematics, composition of functions is an operation that takes two functions f and g and produces a function h such that h of x is equals to g of f of x. In this operation, the function g is applied to the result of applying the function f to x. The symbol between f and g is a small open circle. When replacing one function with another, be very careful to get the order correct because compositions of functions are not necessarily commutative. The composition of two functions g a to b and f b to c denoted by f of g is defined by f of g of a. This means that first, function g is applied to element a, mapping it onto an element of b. Then, function f is applied to this element of b, mapping it onto an element of c. Therefore, the composite function maps from a to c. In this picture, you can see that the outside function is f and the inside function is g. Evaluating composite functions. Example: find f of g of x, and the given is f of x is equal to 3x minus 1 and g of x is equal to x cubed plus 2. If we look at the expression f of g of x, we can see that g of x is the input of function f. So, let's substitute g of x everywhere we see x in function f. F of x is equal to 3x minus 1. F of g of x is equal to 3 g of x minus 1. Since g of x is equal to x cubed plus 2, we can substitute x cubed plus 2 in for g of x. F of g of x is equal to 3 of g of x minus 1. 3x cubed plus 2 minus 1. Since you substitute the function of g of x to f of x, 3x cubed plus 6 minus 1 is equal to 3x cubed plus 5.